Okay, so this is a continuation of the mock exam. These questions are from the Edexcel IGCSE Physics Paper 1, which also is the double award science, the physics paper. So we went through questions 1 to 5 in the earlier video. This is question 6. Hopefully you found the first video useful. My students had already gone through it with me, so it was quite a quick run through for the first 5 questions. Question 6, we'll make sure that we go through it a little bit more slowly. The photograph shows a toy car, so it's made of a metal can and a rubber band. When the toy car is pulled backwards, energy is stored in the elastic store as the rubber band is twisted. Okay, so the rubber band stores the elastic energy. Oh, I didn't know what I was saying. When the car is released, some of the energy from the elastic store is transferred to the kinetic store of the car. So that's going to turn the wheels, and the remaining energy is transferred into the thermal store of the surroundings. In other words, it's energy, unwanted energy, which is a consequence of the energy transfer. State what is meant by the principle of conservation of energy. Well, that's the idea that energy cannot be created or destroyed. Okay, it actually just changes from one store to another. In this case, it goes from the elastic store, some of it goes to kinetic, which is the useful output, and the rest of it goes to lost energy to the surroundings as heat or thermal store. Okay, this new term of the store is the different ways where energy can be deposited. So it can be stored as kinetic movement, it can be in the potential energy of the rubber band, the elastic band, and it can just be in the molecules wasted as random energy of the molecules as heat. Okay, so that's the first bit, knowing that you know what the principle of conservation of energy is all about. That's 1 mark. The car is then pulled backwards, so there's 165 joules of energy in the elastic store. Well, that's the input energy. That's where the starting point is. When the car is released, this energy is transferred to the car's kinetic energy store with an efficiency of 15%. So that means only 15% of the 165 ends up as kinetic energy. And so state the formula linking efficiency, useful energy, output, and total energy output. Yeah? And total energy output. So the efficiency, useful energy output, and so on. Now I think I just want to clarify with the mark scheme, because I may have written my answer out incorrectly. So if I look for the answer for question 6 in the mark scheme has question 6 as, this is the mark scheme, hopefully we can see it. So it's the useful output over the total energy output. Okay, so total energy output is equal to the energy input. Okay, so I should have written in my answer, that's the total energy output. So I'll need to go back and check that I didn't lose a mark from some of my students. So we'll do that when we next meet. Okay, so the useful output is actually equal, the total output includes the wasted energy. Okay, so I misread the question initially. Total output. Okay, going over the page, if the energy output of kinetic energy, the total output energy kinetically is equal to the input energy, which was the elastic store, which was 165, multiplied by the efficiency, and we said only 15% of it ends up as kinetic energy. That means 15 out of 100 of the 165, 25 joules ends up as kinetic energy. The rest of it is wasted, so 165 minus the 25 is, oh, I've written this wrong too, so I must have been sleepy when I did this question. 165 minus 25 is 140 joules, which ends up as heat, or the thermal store. Okay, so it wants you to draw this efficiency as a Sankey diagram. Well, the Sankey diagram is basically the visualization of efficiency. The input's always drawn on the left. The input was the elastic input energy, which was 165 joules. Only 15% of it, so this should be roughly 15% of the width of the total here. So I've kind of drawn it to scale, and you need to make sure that you know that you've got to do that. And then the rest of the 85% of the input energy, so the width of these arrows represents how much of the 100% goes each way. Usually wasted we put down, and the useful we put across on the Sankey diagram. So I hope that makes sense to you if you didn't know. So Sankey diagram is about energy transfers. It goes from here to here, and 85% goes out. So the shape must be correct for 1 mark. The energies must be labeled correctly for each of the 3 parts of it, and the scale should look correct to the eye. Okay, it doesn't have to be exactly correct for GCSE. Hope that makes sense. So that's the continuation of question 6. There's a part C. The car, it says, is pulled backwards again. When released, 45 joules of energy transfers into the car's kinetic store. So you pull it backwards, the elastic band takes up the energy and then releases it in 45 joules into the kinetic store. So it says the car travels a distance of 7.5 meters during this energy transfer. So the kinetic energy moves the car that much distance. But first of all, it wants you to state the useful work done on the car. Well, the useful work done on the car is the kinetic energy gained. What it says is 45 joules, so you simply have to write 45 joules there. Okay? The useful work done is the energy gained by the kinetic energy. Okay? So that's the same as the 45 joules that they say has been transferred. That's all you've got to do. Some people thought that was too simple when they were doing the exam, and they started doing a calculation and got it wrong. Then it says, calculate the mean accelerating force acting on the car. So they want you to calculate a force. Well, they just told you that work done is 45 joules. We know the force is what we want to calculate. So then we also know that it travels 7.5 meters when it had been doing this work. So to do this work, it created the kinetic energy. So 45 joules must equal the force times 7.5 meters. So you just change the subject of the formula, and you see the force is 45 over 7.5, which gives you the answer of 6 newtons. Hope that makes sense. Feel free to stop the video at any stage and go through it, copy what you need out, and improve your original answer. Okay, question 7 is another question on electricity. So it says, what is meant by the term electric current? The only definition is electric current is the rate of flow of charge. So you can't just say it's electrons flowing or whatever. The official definition is the rate of flow of charge. It doesn't have to be electrons. It can be any charge. Any charge flow would be defined by this current definition. Okay. Then you've got a diagram showing an electric circuit used to test a fuse. So the fuse is in there to test a fuse. So you've got to think of what they mean by testing a fuse. So you've got a DC power supply, positive and negative, a resistor, a fuse, an LED. And I've added an ammeter because it's asking for that later on. It says give a reason why an LED is included in the circuit diagram. Well, the LED is basically emitting light, and it shows the current is flowing. So if the current is flowing, that means the fuse must be working. So that's what they want you to know to test the fuse. Okay? If it doesn't light up, it shows the fuse is blown. And then it says, so that makes sense. So add another component to the circuit in the diagram to measure the current in the fuse. Well, anytime you add an ammeter, you've got to put the correct symbol, obviously, and it must be in series with everything else. So it must be in series with the fuse and the LED. Okay, I think that's quite clear. The second part of question 7 is then showing 3 lamps in a parallel circuit. So this diagram shows a different electric circuit containing 3 different lamps. Now you see the 3 different lamps, they have different currents. For example, the first one's got 0.2, the third one's got 0.3. So I've represented each 0.1 with 1 arrow. The current is always conventionally drawn going from positive to the negative side of the power supply. Okay, so I've drawn 6 arrows to represent 0.61. So 6 arrows start, 2 of them go to lamp 1, 3 of them go to lamp 3. That means only 1 goes to lamp 2 because you only had 0.6 amps in the first place. So I represented each of the arrowheads as 0.1 amps. Okay, so you can see that this is the rule for current splitting at junctions. Over here, 6 starts, 2 go this way, 4 go down to the other 2 bulbs, 1 goes this way, 3 goes down, and then they join again, the 4 come back together, and at the end you got 6. So this is explaining the circuit rules for parallel circuits of how the current splits. So all you've got to work out is how much is I1, which is lamp 2, 0.1 amps, and I2, which is at the end is all of the currents joined together again is 0.6. And it says explain which lamp will be the brightest or is the brightest. Well, lamp 3 is the brightest because it has the highest of the 3 lamps in terms of current. So 1 mark for this, 1 mark for working out is because it has the highest current. Well, if it has the highest current, it gets the greatest amount of power because power is voltage times current, and because they're all in parallel, they all get exactly the same voltage. Okay? That's the question 7. Question 8 is about hailstones. Well, hailstones, if English isn't your first language, are bits of ice which fall from the sky. So it's like frozen rain. Sometimes they can be quite large. So they want you to describe how you could determine the density of a hailstone. So obviously you will need to use the density equation, which is mass over volume. If you do that, if you just mention that you know it's a density equation, you'll get 1 mark because you know which equation to use. So you have to, they say assume the hailstones are spherical. So if they're spherical, you need to know that the equation for the volume of a sphere is 4/3 pi r cubed. Okay? So when you do that, you've got to say, well, to be able to work out density, first I've got to measure mass. Well, with what? You have to use a mass balance. So these are any way where you can have valid points towards your 4 marks. Then you can measure the diameter of the hailstone using calipers or a micrometer or a ruler to estimate the diameter. Yeah. So obviously the micrometer is the most accurate of these 3. You could say you would have to take repeat readings and average, because this is further detail that would give some students extra marks in a different way. Take readings at different orientations, yeah, to make sure that you got a good average. And then you calculate it using the formula that we've been given. Okay? Then calculate it using the formula. There's many ways of doing it. Okay? And then it says in the next part, the mean volume of the hailstone is given as 1.1 centimeters cubed in the next question. So, and the mean mass of the hailstone is given as the mass of 0.94 grams. So they just want you to show that you can calculate the mean density given these values. So you're simply using the same equation that you already know as mass over volume. You put the values in, you'll get about 0.8545, and you round it up to 2 significant figures because each of the data points that you've been given, 1.1 and 0.94, are both only 2 significant figures. They want you this time to get a mark for putting the right units. Well, if it's in grams and centimeter cubed, the unit will be grams per centimeter cubed. Okay? So that's the first part of question 8. It then is bringing in convection current ideas of what happens to hailstones in the clouds. Well, hailstones can be lifted, it says, to the top of clouds. So this is showing by these 2 arrows, which if you've studied convection currents, you'll know is something to do with the movement of hot air and cold air. Hot air rises, cold air sinks. The diagram shows the movement of the hailstones in a cloud. It says, suggest how hailstones are lifted to the top of the cloud by convection. Okay, so it's a convection current. So this is what we were talking about before. So you set up a current, and so you know that in convection current, warm air must rise. Well, it gets warm because the ground is warm. The further up you go, the colder the atmosphere becomes. So you've got the heat source is the ground. That heats up the air. That warm air rises, and warm air expands because heat causes expansion. As it expands, it becomes less dense than the cold air around it, and a convection current is set up. And you could go on and explain that when it gets to the top, cold air will sink, and this convection current continues. Okay? So this is from the solids, liquids, and gases part of the syllabus. Okay. The next part is about question 9, which is from the pressure topic, which is in the same area of the syllabus. Question 9 is showing you a diagram with an empty container that has a hole in the top. So you can mention that. You can see the hole here. It wants you to describe how the air molecules in the container exert a pressure on its inner wall. So this is the kinetic theory of gases. So it says the molecules, which are moving randomly, that's extra detail, so it's in brackets. Well, you really need to say molecules collide with the walls. Collisions produce forces on the walls each time there's a collision, microscopic forces. And force per unit area, so the area of the wall, creates the pressure because pressure is force over area. And that will allow you to get your 3 marks. Okay. The container, it then says, is heated for a long time. Okay, so explain what happens to the number of molecules in the container when this happens. Well, an increase in temperature increases the speed of the molecules. So you can get these 2 marks here from anything from the list that I've put. The higher speed or kinetic energy increases the chances of the molecules escaping out of the hole at the top, because obviously more of them will be able to move to the top of the container. So the number of molecules will decrease gradually. More of them will escape through the hole. Okay, so this is about kinetic theory of gases. Okay, so that's part 9. And then it says, I think, yes, I'm just checking that I haven't put the questions in the wrong order. That's right. So we did the 8, which was also about hailstones, convection currents. Then it's 9, similar topic, convection currents. Part C, then, of question 9 to do with pressure. A lid is then placed on the container, so that kind of seals the hole or blocks it. The container is allowed to cool. So now instead of heating, we're cooling. As the container cools, it collapses. So why does this happen? It wants you to explain why it collapses. As it cools, the molecules move with lower speed, or lower kinetic energy, you could put, / kinetic energy, So there will be fewer collisions per second. So if there are fewer collisions per second, that'll be less force than before. So there will be a lower pressure inside, because remember, pressure is force over area. Pressure P equals force over area. So the force of the collisions is lower, the overall pressure inside will be reduced because each collision will be less forceful. But the pressure outside the container hasn't changed. It doesn't change. So pressure outside will now be greater than the pressure inside as it cools, the can cools. That pressure difference, causes a force strong enough to collapse the container, to crush the container. Okay, so this is again the kinetic theory of gases. Heat increases the pressure and cooling it reduces the pressure. The next question is question 10. So question 10 is about an amusement park, a vertical drop. So they want you to know that at the top it's got potential energy and then it goes down to kinetic energy. So it's a vertical drop ride. A car is pulled to the top of a vertical drop by mechanical work or energy transfer. I've added that in. to help you understand that it's the energy topic. And then released from rest. So the released from rest means initial velocity is 0. The car then falls freely because of the force of gravity. Remember, g is 10 meters per second. Acceleration is gravity. In this case, acceleration due to gravity is being 10. They want you to calculate the speed when it falls 18 meters. Well, if it falls 18 meters, you can use the constant acceleration formula as long as we ignore any air resistance. V squared equals u squared plus 2as. U is 0. 2 times 10 for acceleration. S, they've told us, has dropped 18 meters. So that means v squared is 360. Take the square root of 360, comes out to 18.8. You can round it up to 19 because, again, they've only given us 2 significant figures. And you get 3 marks for the calculation as shown. Feel free to stop the video if you want to copy down any of the answers. So that's the beginning of question 10. You then have to go into the kinetic energy formula. They want you to explain that you know that kinetic energy is half times the mass times the velocity squared, or the speed squared. So I've just made sure that I'm using symbols, but I'm showing you that m is mass and v is speed, so they can't say, I don't know what m and v stand for. It then wants you to say the mass of the car and its passengers is 2.1 tons. Well, a ton, it tells you 1 ton is 1,000 kilograms. That means the mass is 2,100 kilograms. They want you to calculate the kinetic energy of the car when it's fallen 18 meters. Now remember that we worked out when it falls 18 meters, that the speed was 19 meters per second. So you're taking the answer of the velocity or the speed from the previous calculation you made. So you're multiplying the 2,100 by the speed you calculated. Approximate speed is fine. If you use the approximate speed, it will come up to 380,000, and you just put that as your answer. They've already told you that the energy is in joules, so you don't need to worry about the unit in this question. Part C, it says the actual speed of the car when it's fallen 18 meters is lower than the value calculated, in part A. So it'll be lower than 19 meters per second, it's saying. Describe the energy transfers occurring from immediately before the car was released, where it had gravitational potential energy. So it was a potential energy that hadn't been, it's just in due to its position above the Earth, and it changes to when the car has fallen 18 meters. Obviously, we thought it was all going to kinetic energy if we ignored the air resistance and friction. But you have to refer to energy stores, which is a new terminology that in the last few years that they want you to use. So it goes from the gravitational potential energy stores, some of it goes to kinetic energy, and obviously what else they want you to say, or why didn't it all go to the kinetic energy? So you've got to mention energy stores clearly in your question and the transfers that happen. So energy is transferred from gravitational potential energy to the kinetic energy store. This type of energy transfer is called mechanical energy transfer because work is being done. This time the work is being done by the gravitational field of the Earth. Okay, but it's still work, physical work is done. When physical work is done, we call it mechanical energy transfer. Some of this gravitational potential energy is also transferred to the thermal store or heat by friction in the shaft, for example, to the car or the shaft, so they could the rubbing friction between them will actually increase the temperature of the moving parts. This type of energy transfer is by heat or radiation or by heating, and it goes to the surroundings. Okay, so as long as you're mentioning, so this energy is by heating, or you could say it's by radiation. That's how you get your 10 marks in this question. Okay, so I think we're going to be able to finish it in one video. Question 11 is about wavefronts and reflection. So wavefronts are these parallel lines, and the arrow shows the direction of the travel of the wave, which in light would be a ray. They want you to draw the normal, so it says draw the normal at the point where the direction of the travel of the waves meets the side of the boat. This is the side of the boat. So this line is representing the side of the boat. So the waves come here and they're going to bounce off. So the law of reflection says the angle coming in must be equal to the angle that they reflect at. So you need to make sure you've drawn the reflected ray and therefore the wave fronts going off at the right angle. Okay? They want you to measure the angle of incidence that I've drawn here. Measure the angle of incidence. A lot of students were measuring the angle to the boat. Angle of incidence is always measured to the normal, which is what you need to remember in these questions. Okay? Once you've done that, you've drawn this, then you get 3 marks for how you've drawn the reflected ray. If there's 3 parallel wave fronts, yeah, because you had 3 going in, draw 3 parallel to each other. They should have the correct separation between them, the same as before. They should have the same wavelength in effect, and the angle should be correct. That you've made sure that visually to the eye it looks like you've drawn the angle reflected equal to the angle that's incident. Okay. It then wants you to know the boat starts to move, creating its own waves on the surface of the water. Surface water waves are transverse. They want you to just describe the difference between transverse and longitudinal waves. And in fact, because it's a combination paper put together for the mock exam, we've had this question before earlier in the paper. So transverse waves vibrate at right angles to the direction of travel of the wave, and longitudinal waves vibrate parallel to or along the direction of the travel of the wave. They just want you to know the actual basic definition of transverse and longitudinal. Again, feel free to stop the video at any stage when you want to go through the answers in more detail or make notes. Okay, then it's showing you a Doppler shift, what's called a Doppler shift. So diagram 2 shows the boat moving towards an observer. So the observer standing here. It says, explain why the frequency of the water waves measured by the observer, so from the observer's perspective, is larger than the frequency of the water waves created by the boat. Okay, so from the observer's perspective, the wavelength or the wave fronts, the distance between the wave fronts gets smaller. Yeah, because a boat is moving in the direction of the waves it's making. So they kind of get compressed. So the wavelengths get smaller. That's what you've got to say. Or the wave fronts are closer to each other. The speed of the waves is constant, hasn't changed. The speed of the waves actually only depends on the depth of the water. So you're assuming the speed of the waves is constant. And since you know the wave equation, they want you to be able to use it. V is constant. Well, if lambda gets shorter, lambda is the wavelength, then the frequency must compensate and go up. So if lambda halves, the frequency would double, and so on, because they're inversely proportional. That's how you get your final marks for this question on waves. Okay, the next question is about a parachutist, which is another very common question. It's about balance forces and air resistance. So the question is about a parachutist, leaves a helicopter that is hovering above the ground. The parachute is initially at rest, so again, U is 0, falls vertically downwards, so it gains kinetic energy. So it's potential energy to kinetic energy, so it's a repeat of previously asked questions. And this again, because we've got a combination paper here where we've taken the questions from units 1 to 5 for you to try. The calculated speed of the parachute is after they've fallen through a distance of 1,300 meters. S equals 1,300 meters. Remember, S is displacement or distance. Ignore the effect of air resistance, it says. So this time, again, we can use the same equation, v squared equals u squared plus 2as. This is really good that you've had this twice. This is the most difficult equation in motion that you need to remember. So this final velocity squared equals the initial velocity squared, where u is 0. So the u squared just becomes 0. A is the acceleration due to gravity. S is the distance they've given us. Obviously, the further you fall, if there's no air resistance, you'll keep accelerating at 10 meters per second, 10 meters per second squared. Multiply these numbers together, you'll get 26,000. That's v squared. Don't forget to square root it. You square root it, you'll get about 161. So you can round it up to 160 and you'll get the marks if you do so. You only need 2 significant figures again because they only give us values accurate to 2 significant figures. Part B. When the parachutist is much nearer to the ground, they open their parachute. Yeah, obviously they want to slow down. This is what slows them down. Explain the change in speed of the parachutist. Use ideas about forces in your answers. Remember, this is about balanced and unbalanced forces. There are 2 forces involved here, weight and air resistance. If you just mention that, you get 1 mark, so you know the 2 forces involved. Any 3 from this list will get you the 3 marks. When the parachutist when the parachute opens, the air resistance is greater than the weight because obviously it captures more air, has a much bigger surface area than the parachutist without the parachute. This creates a net force upwards, which is therefore there is a resultant or unbalanced force, and this is Newton's second law. So F equals ma. The A will be in direction of upwards because the net force is upwards, because the air resistance is greater than the weight. Therefore the acceleration must be upwards. Yeah? So that you must mention that the acceleration is upwards or negative or against the motion. The air resistance decreases as it slows down. So this only occurs for a short time. Okay. As we have now come to the end of the exam, the last bit you need to do is to continue with the question 12. It is observed that from when the parachute opens, to just before the parachute touches the ground, the gravitational potential energy store and the kinetic energy store of the parachutist both decrease. Well, if they're both decreasing, where's the energy gone? Remember the conservation of energy principle? So energy must still be conserved, it says. Justify these observations. So they're referring again to the law of conservation of energy, where energy can neither be destroyed nor created. So if both of them are losing, gravitational potential energy is losing because it's losing height, kinetic energy store is losing because it's losing velocity or losing speed. So you need to say that gravitational potential energy decreases with height loss. Yes, because GPE is mg and is directly proportional to the height. Kinetic energy decreases as the parachute reduces speed. You can put the equation in. Kinetic energy is proportional to speed squared. So both of these are decreasing. But frictional forces or air resistance work against the falling person slash parachutist, which causes the thermal energy store to increase, So any friction, remember, causes some heat even if you can't feel it, due to these frictional forces. Some of the heat is lost to the surroundings due to the temperature difference between the parachutist and the air. And this loss of heat can be due to conduction, which just means atom-to-atom vibrations, or radiation, which is basically anything which is warmer radiates more energy than it takes in. And therefore this is a thermal energy transfer. So these are all different terms that you can use to get the maximum marks. So that should be a total of 110 marks. I think I would have got 109 due to that mistake I made in the efficiency equation of misreading the question. So that's the motto. Always read the question carefully. Use the underlining technique I've demonstrated in this paper. And if you found this video helpful, it's quite a long video, so the rest of it's question 6 to question 12 is 33 minutes long. So if you found it useful, please give us a like, share the video with your friends so we get more viewers, and please subscribe. If you subscribe, we will be able to fund this channel and create more videos for students at GCSE and A-level in physics. Thank you very much for your time, and see you at the next video. Bye.